Okay, the previous class we learned about forces on the plane surfaces. Now we go to the curved surfaces. For example, we have the curve like this, the curved surface. Right. So how to solve this kind of question when it is curved? Whatever shape, maybe like this, maybe like this. So the first we need to set the projection. Okay, this is we need to set the projection into horizontal. Okay, this is the horizontal projection and this is the vertical projection. So that means we need to separate X and Y component into projection. This is projection in horizontal. Okay, this is H here. And this is vertical and vertical. Okay, vertical. Right, of the curve surface. Okay, remember that the last class we deal with the force as a plane force submerged in the water. It is only the vertical component. Okay, that means we have the force like this. I hope you can remember, yeah. Okay. So for this case, we need to consider two axes, okay, horizontal and vertical, because this is the curve, all right. Of course, in the curve there is this is the curve surface, all right. So when we draw the free body diagram, we must take out the curve element. So I try to draw again. Okay, and then I take out this portion and this portion because this is only the element that we consider. Okay, from this one, as you can see from this one, this element, I take out to become like this. Okay, definitely when this is the element, we have the weight. Okay, we have the weight acting downward. We have the force. Okay, for example, we have the force here to here. We have the horizontal force because it is acting horizontal. And definitely we have the vertical force acting to the horizontal projection. This is quite easy after you understand about the concept of plane surface, you can apply directly to the curved surface. All right, and then we have the force acting perpendicular to the other side, to the curved surface. Okay, so from here, we need to specify the resultant force. This is the resultant force. F, we call Fy, and this is the resultant force in X direction. And of course, we have the resultant force. This is Fr, which is always act, okay, in two components, which is Fh and Fv. Okay, so in order to solve the Fv, okay, Fv, where is Fv? Fv is, Fh, okay, let me remark here, Fh, this one, Fh. Okay, FH can be found using the equation F equal to gamma HA. Because why? Because FH is, you can see, equal to this. Okay, can be solved using gamma gamma HA. Okay, for the weight, we can use the weight of the liquid block, right? For the weight here, to calculate the weight is basically equal to the weight of liquid block, which is rho GV, the formula. And then since this is under static, okay, under static case, static equilibrium, alright, we can put this way, summation of force in x direction, basically, okay, force in H is equal to force in x. Summation of force in y direction, basically force in V equal to force in y plus minus weight. Okay, I will explain later on lah because why it is plus and minus. Okay, this is the general rule lah. Okay, I want to show you the example one. Okay, so now we have the example, compute the horizontal and vertical component of hydrostatic force on the quarter circle panel at the bottom of the water tank. Alright, when you want to solve this question, you must set the projection in horizontal and vertical component. So I set this as the projection. Okay, I set this projection in vertical and horizontal, the horizontal and vertical projection. Okay, and then you can see clearly the projection of plane. Okay. Alright. And this is the projection in horizontal. Yes. So now you can see in this direction as well as in this direction. So from here, in order to calculate the horizontal force, okay, we must draw the force distribution like this. I think you cannot see. Maybe we can use different color. Okay, this is force distribution. Okay, that means we have the resultant force. F. Okay, we can call as the F of R or anything else. Okay, so how to calculate the F? Okay, we know for sure F is basically gamma HCA. Alright, so gamma is the gamma of water. Okay, it is given gamma of water 9798. However, the one not given is HC. The HC is the from the surface, okay, from this datum to the centroid of the plane. Where is our centroid? This is our centroid. Okay, so 5 meter plus width half of this, which is 2 over 2, you will get 1. So this is half. So it is 1 meter. So 5 plus 1 equal to 6 meter. Therefore, F here that we want to calculate in the vertical direction, force we say in horizontal, yeah. Force in horizontal. Okay, horizontal force basically gamma 9790 multiply with HC, which is 6 meter, multiply with the area. So this is the area. So what is the area? Which is 6 meter. Okay, this is area 6 meter multiply with 2 meter. So 6 multiply with 2 is 12. So the answer here should be 704,880 Newton. Okay, however, to calculate the vertical force, all right? In order to calculate the vertical force, we must look at this one. Okay. I try to draw, yeah, to make sure you clearly understand. All right. Okay, this is the block. Definitely, we got the resultant force Fr. So the Fr must be act in this direction and this direction. Okay, sorry. All right. So this is F. Okay, this is F, R, X. This is F, R, Y. Okay. The one previously we calculate is basically we do the projection, remember? And then we consider this prism. Okay, we have the resultant force F, H. So basically FH we can equate directly equal to F Rx is equal to FH. Okay. So this is what we discover lah. However, how to calculate FRY? FRY basically is the weight. Okay, the weight of the liquid block. So how to calculate the F? Okay, the weight. The weight of the liquid block is basically equal to rho G V. So rho G is a gamma V. Gamma of water is 9790 given already. However, to calculate the volume, how to calculate this volume? How to calculate this volume? So the rectangular volume minus what? Anyone?
Quarter of circle.
Perfect. Quarter of the circle. So the cubic one is 6 meter multiply with 7 meter multiply with 2 meter. This is for rectangular. Okay. Minus with the quarter of the circle. 1/4 pi. R is, this is radius. From here to here is R, which is 2 meter. Okay. Multiply with the depth, which is 6 meter. And then you will get your answer should be 637,823 Newton. That's it. Very simple. Okay. For this one, I give you homework lah ya. Later on you will do. Okay. This is quite simple. You need to do the projection and then you need to solve lah X and Y direction. Okay, now we go to the buoyancy. Buoyancy of submerged and floating body discovered by Archimedes by two laws of buoyancy. A body immersed in a fluid experience vertical buoyancy force, which is equal to the weight of fluid it displays. Okay, now let's consider the arbitrary shape. Arbitrary shapes can be any kind of shape like this. Alright, this arbitrary shape is submerged in the water. So let's specify the vertices. Okay, the point lah basically. Alright. So this refer to A, this refer to B, this refer to C, this is D, this is A, B, C, D. Okay. Okay, and then this is H lah. And this is K. Of course, this is arbitrary. We're gonna have the weight. The weight should act at the centroid. So in here we have the force, okay, acting in vertical direction Fz prime. We also have the force at the top surface Fz. Okay, and then it is under the fluid. Sorry, it is inside the fluid. Okay. The force on the immersed body are gravity and pressure of surrounding fluid. So from here, the upper surface, okay, you can see the upper surface here. Okay. Vertical component Fz, okay, is equal to the weight of volume A, B, C, H, D. So you can see A, B, C, H, D. Okay, so that means Fz is basically equal to the weight volume of A, B, C, H, D. That is Fz, the upper surface. For the lower surface, Fz prime, okay, is equal to the weight of volume, okay, A, B, C, K, D. Where is it? A, B, C, K, D. So all this. All right. So that means the strength of Fz prime is equal to the combination of A, B, C, K, D. On the other hand, the strength, okay, of Fz is only A, B, C, H, D, the blue color. The difference between the two volume. Now we go to the difference. So what's the difference when you try to when you try to deduct between A, B, C, K, D minus A, B, C, H, D? You will get the pink color. Okay. Volume of body DHCK. Where is DHCK? That is the difference. Now look at the buoyancy. Okay, now look at the buoyancy. The buoyancy is denoted by FB. FB must be X vertical direction. Okay, so it is also FP is basically equal to the Fz prime minus Fz. Okay. So it is basically equal to the weight of volume dHck. Okay, the pink color lah. So that means the weight of the pink color is basically equal to the buoyancy. Now, the buoyancy force on any body is equal to the weight of displaced volume. So this is what I mentioned lah. FB equal to the gamma fluid displaced volume. If the DHCK, the small one, the purple color is in equilibrium, W is equal to the opposite to FP, which means that the density of the body of the fluid are equal lah. Okay, I will later on explain. For example, if the weight of the body is more than the buoyancy force, the body will sink. Okay, for example, we have the balloon. Okay, this is the helium balloon. When you try to loose your hand, it will move upward. Okay, until at certain altitude, it will stop. This is due to the buoyancy force is equal to the weight of the displaced volume. Okay. From here, we are living in the atmosphere. Our atmosphere separated by different density. Okay, at the ground, the density is quite higher. When you go to higher altitude, the density is quite lower. All right. So I want to draw an attention. Okay, let's say this is considered as the atmosphere. At this level, density of atmosphere is high. It's quite low. Quite low. The higher the altitude, the density is very, very small. The density of the air. Okay. So when you have the balloon inside the balloon is the helium balloon. It got its weights. And then this balloon gonna have the FB, the buoyancy force. All right. So the balloon will rise because the FB is more than the weight. Okay. Now, do you get it? The FB is basically like this. FB directly depends on the atmosphere density, gamma of the atmosphere, gamma of air, gamma of air. This is displaced volume of the balloon. Okay, so that means the buoyancy is changing. Okay, the buoyancy is changing with altitude. Different altitude will have different buoyancy. So at the lower altitude, the buoyancy is very big because of big density. Until at a certain point, the balloon will stop because FB now is equal to the weight of the helium. Okay, now do you understand the concept? Why the balloon will stop rise? Because of the buoyancy is equal to the weight of the helium balloon. Okay. So, okay, let me check. Okay. Alright. If FB pass through the center of volume of the displaced body, center of buoyancy level with B or CB on the drawing. Okay. Layer of fluid. Sum of the weight of each layer displaced by the immersed body. For example, we have the ball. Okay. This is the pool. We have ball here. And this ball is submerged into different fluid layer. Maybe this layer, this fluid. Another layer, different fluid. Okay, so how to calculate the buoyancy force when you encounter different layer? You must use the summation of force, okay, FB is equal to summation of different gamma. Gamma of I minus displace of I. Okay, I mean different lah. This is maybe, this is water. This is oil. So you must use gamma of water multiply with the volume of what? Volume of this. Okay, we consider as a maybe V1. Okay, multiply with V1 plus gamma of oil multiply with displaced volume of this one. Okay. So this is displaced volume 2. This is how to calculate lah. Okay. So when the floating body, that means it is float, consider a body in a liquid with a free surface. Okay, that means it is exposed to the atmosphere. So this is how it float. That means it is on top of water. This is the different case, yeah. We have the arbitrary shape. Okay, and then you try to submerge in the water. However, the body rise and float. That means it has the floating. It will float. Alright. So we have the case. We need to label A, B. Okay, H. Okay, definitely we have the weight. And then we have the F, Z prime. Okay. Like before, the gravity and pressure force act on the body is AH, BK. Fz prime is equal to the weight of volume of liquid AK, B, FB upward, buoyancy point upward, and it is equal to Fz. So basically this is equal to FB lah, buoyancy force. Right. So I want to highlight, in order to calculate FB, okay, it is gamma V. V, remember dV slash is a displaced by liquid. Do you think where is part displaced by liquid? On the top or at the bottom? Which is displaced by liquid? Okay, A or B? Which one is displaced by liquid? The one that it is being displaced. Supposedly it is nothing, 0. When you submerge one object, it displaces the liquid. Which portion? AHB or AKB? Class? Any idea?
AKB.
AKB. Okay. So this one, I mentioned before, when you calculate the ball here, it displays 100%, right? This floating, it is only displaced on the bottom layer. The top is not displaced. It is not displaced the liquid. Okay, the yellow color displays. So to calculate here, FB is equal to gamma of what? This is gamma of this fluid. Okay, gamma of this fluid must multiply with displaced volume. This displays A, K, B. Okay, A, K, B until this one displays. Okay. So we try to do one example. All right. A crane is used to lower weight into the sea. A crane is used to lower weight into the sea. This is the weight lah, the concrete block with the density 1025 for an underwater project. Find the tension in the rope used by the crane due to a rectangular concrete. Okay, block with the dimension 0.4, 0.4, 0.3 meter when it is suspended in the air. Okay, when it is suspended in the air, do you think it is submerged? Do you think it is displaced? It is displaced by the liquid? No, right? When it is in the air, directly, the force, okay, the tension of the rod is equal to the weight of the block. So, tension of the block is equal to the weight of the block. No buoyancy. The buoyancy will take place when it is submerged in the water or in the liquid. Okay. So to calculate the weight of this block, definitely weight is equal to rho G V. Okay. So rho of the concrete. Okay, what is the rho of the concrete? 2,300. Okay. 2,300, gravity 9.81, and the volume of the block here is 0.4, 0.4, 0.3. And the final answer should be 1083.02 Newton. Okay, this is simple static, yeah, we learned before, the static. However, when this concrete submerged in the water and then you ask the crane operator to pull it up, so definitely it will have the buoyancy. You can see here, FB, it has the weight and it has the tension. All right, the tension lah. FT, this is FT, yeah. FT, the tension. So based on this, we draw free body diagram. The summation of force, we can do the summation of force, okay, positive outward in the y direction equal to 0. Okay. We consider this is equilibrium, yeah. Try to move at the initial stage equal to 0. So what force we involve? Ft, or we call FFT, only T je lah, tension. Sorry, tension. Tension plus FB minus W equal to 0. So now your tension become, okay, weight minus FB. Maksudnya that means it is less tension lah, because buoyancy help you. You try to leave rock in the water, compare in the air. Of course, when you try to leave a rock in the water, it is much easier compared to in the air because of buoyancy. Buoyancy help you. Okay, so weight is we discovered before. This is the weight. Okay, this is, you can see, this is also weight. Okay, this is T is equal to W is equal to this one. We discover the weight we know. FB, we don't know. How to calculate FB? It is gamma of displaced, gamma multiplied with displaced object. Okay, by the displaced fluid by the object. Displaced. Alright, so gamma is rho G lah. So where is gamma? So rho of this one, rho of sea water, gravity, and V displaced. Okay, displaced. So gamma of C is, rho of C is 1025, gravity 9.81. The displaced, what do you think? It is displaced 100% or displaced half-half? Like a floating. It is, you can see, fully immersed. Oh. It is fully immersed. So that means we must consider the volume fully immersed. Alright. What's the volume of fully immersed? The same thing, 0.4, 0.4, and 0.3. Okay, we calculate the buoyancy. We discover it is 482.65 Newton. Finally, to calculate the T here, tension is W minus the FB. W is 1083.02 minus 482.65 Newton. You will get 600.368 Newton. Okay. I think that's all. Okay. For this one, I will give you homework as well. And don't worry, I will share you the solution. But I need you to do the homework first. Okay. This will help you for your test too. Okay. Test 1. Okay.
Doktor,
Please.
test 1 bila doktor?
15.
Hari bulan 11.
15 November. Okay, tahu tak? Do you know which topic cover test 1?
Tak tahu doktor.
Okay. Cover from week 1 until week 6. Okay, until Bernoulli equation. So now we are in buoyancy. We are week 4. I hope that I can finish lah week 5 and week 6. Okay. I think that's all. Please do this one. Example 5, 6 and 7. 5, 6. Example 4, 5 and 6 ya. Okay, I think that's all. Selamat bercuti. Happy holiday everyone. Stay safe. Okay. Sambil tu jangan lupa belajar. I end my session with Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam doktor. Terima kasih doktor.
Okay.
Thank you, doktor.
Thank you, doctor.
Thank you, doktor.
Thank you, doctor.